All right, here we go. So find the geometric mean between 18 and 50. Now remember, that just means it's the square root of 18 times 50, but of course I'm not multiplying that together. 18 breaks down to 3 radical 2's. Everybody with me on that? So this would be 3 times 50 breaks down to 25 and 2. So the square root of 25 is, and then there were 2 2's left inside, so that means a 2 can come out. So you should be able to say that's just what? 30. Now if you type that in the calculator, yes, your calculator would just say 30. All right? But if it wasn't a perfect square, your calculator would not know that. All right? So anytime they find the geometric mean, and this is probably the last time you're going to hear somebody say geometric mean. All right? Because it's just, to me, of no value. All right? So, again, the rule right now is multiply, take the square roots. That's just a rule. All right? Now, the directions here, all right, we're finding BD, so this is X. We talked about this yesterday. Some of you are saying, well, I can't figure out what's the short leg and long leg. All right? Remember, and I told you, if you don't know what the short leg, long leg is, you're going to have to put in numbers for the angles. Right? Like if you didn't see that, you could just come down here and say, well, I think this is 40, which makes this 50, which makes this 40, which makes this 50. Now you should be able to see the proportions better. Everybody with me? All right? But the other thing I want to try to stress to you right now is the altitude, all right, is what they're referring to when they are asking you about the geometric mean. All right? But in this situation, you would just say what? X over 6 is equal to, I think it's 12 over X, isn't it? Because X is the long leg and 6 is the short leg. Everybody see that? Very important. Now again, when you cross multiply here, you would say X squared is equal to 6 times 12. Notice I'm not multiplying together. Because I know when I take the square root, I automatically see a what? 6. So X is equal to 6 radical 2. Everybody happy with that explanation? All right. And like I said, I'm being pretty thorough here because honestly, I think this is the hard part. Everything else is pretty easy. All right. Here we go here. Again, finding BD. All right. Same as problem number 1, actually, I think. All right, so we're going to say X over 12, which is short leg to long leg, is equal to 4 over X. So X squared equals 4 times 12. So X is equal to 4 radical 3. You should be good. Everybody okay with that? All right, number 4, we got that one. Number 5 is the same. Wow. Okay, so that's a good problem to have. All right, so let's verify this real quick. All right, so if you didn't know, again, I'm just going to come over here and just randomly put 40 here, which forces this to be 50, 40, 50. Do you understand that? Right? Now, we know it's not 45, 45 because that means they'd all be the same. Sure? Right? So it doesn't matter what number. Right? I'm looking for X. X is opposite the what? And 13 is opposite the... So if I say 13 over X, 13 corresponds to the 50 and X corresponds to the 40. Now, please listen to what I just said there, because I think personally when I got in trouble, that's what I did. I just put angles in, because I knew I could write the proportion if I had the angles. The sides, the triangles themselves are confusing, because they could be twisted, flipped upside down, lots of different ways. All right? So now I'm looking at the 50-degree angle. That's X over what? 15. Everybody good on that? All right, so now does everybody see there's nothing common with 13 and 15, right? So 13 times 15 was that 195? The square root of 195. Did I get on that? All right. So now, number 7 is the one that's actually important, and 8 is the important, and 9 is important. Those are the ones that are really the most important because that makes you do what? Everything. All right, so let's do a couple of those just to make sure. All right, so let's take a look at, we'll just start out with number 7. All right, now because you know the Pythagorean theorem, listen up to me, please. This could save you some time. Right, so you can easily find x, right? Is everybody hearing me? All right, if you know the Pythagorean theorem, this is easy. Is everybody good? Right, so here, don't forget this is 2 times 3, and this is 2 times 2, correct? So this is going to be 2 times something, right? Now keep in mind, 3, please listen, this is how I want you to think. 3 is the hypotenuse, 2 is the leg. So 9 minus 4 is 5. So that's 2 radical 5. Okay, guys, so you're just doing 2 squared plus b squared equals 3 squared. Come on.
Wait, so you use the numbers that are
Yes.
not the...
Right. Plus,
So how do you know it's not the that the 3?
because it's the hypotenuse.
Oh.
Right, because it's the hypotenuse. Always identify the hypotenuse. What? Come on.
This is, and then when you're done with the column, it says, b squared equals 5.
Yes. Brilliant. What?
How do you know to use the factor that?
Because 2 was in each of the other problems, kiddo. 2, 2, 2.
Just because they're in the other two, why don't you do it?
Do we not do Pythagorean triples? If 3, 4, 5 is a triple, 6, 8, 10 is a triple. Right? What? 9 minus 4.
Wait, so the answer is 2 radical 5?
Yes. The answer is 2 radical 5. Really, if that's too complicated for you, just leave it as 6 and 4.
Yeah.
Exactly.
Oh, so then you just do 6.
Okay, here we go. So now I'm trying to figure out what y is. All right? So now I'm back to, I know this right here is 2 radical 5. So again, 2 radical 5 over y, short leg to long leg, is equal to, the short leg is 4 and 2 radical 5.
I thought,
These all have a factor of 2 in them.
this is the test. So in the key it says 4.5, and then I got 4.472, and you got 2 radical 5. Does it matter what we suggest?
I want you to have it as a radical,
Okay.
right?
And then later in the chapter,
Well, it just depends if we're using radicals or decimals. Right? If I said 9/4, you could say 2.25. Right? But radicals aren't written as decimals. All right? Yeah.
Can you cancel the 2 radical 5?
No, we're cross multiplying.
Yeah, I know, but like cross multiplying with
4y is equal to what?
4 radical 5. Because 4 radical 5 is 20. Oh, it's 5 times 5. That makes sense.
Radical 5 times radical 5 is what?
5.
5 times 2 times 2 is 20. So y is 5.
That makes
So if y is 5, what is z? Z is 9.
Oh, wait, that's 4.
That's all right. That's my fault. I kind of broke it down so we could do it. What? Okay, look here, please. Now, instead of doing the Pythagorean theorem, because that kind of messed some of you up. All right, I'm going to come down here real quick and say I have 2 over 5. That is a short leg and a what? That is a short leg and a hypotenuse. What? We're not looking for angles. And then I want a short leg and a hypotenuse. So that would be 5 over z. So 2z equals 25. Z equals 25 halves. Any questions with that? And if z is 25 halves, y I can just say is 21 halves. How did I get that? I just did 25 halves minus 2. And 2 is 4 halves. So 25 halves minus 4 halves is 21 halves. Everybody good with that? $25 halves minus 2 is the same as 25 halves minus 4 halves. Now, personally, look, instead of doing a proportion, I'm just saying, I just see a squared plus b squared equals c squared there. Everybody with me? 25 minus 4. Square root of 21. Radical 21. What is the issue? No issue. Why does everybody see that? Say it again. Oh my goodness, guys. This is the hypotenuse. Man, come on, look. If you're confused, just write down a squared plus b squared equals c squared. I'm hoping in this game you can say, look, if I have a hypotenuse and a leg, I'm going to do what? Subtract. If I have both legs, I'm going to do what? Add. Simple. Hypotenuse, leg, you subtract. Or if that's complicated for you, go ahead and write out the equation. All right, here we go. I want to take a look at number 10. Let's practice number 10. All right, so right off the bat, I'm just going to do 13 over 15. And then I'm going to figure out what that is. 13 over 15 is a... Would somebody please think for themselves? Long leg over hypotenuse. You guys got a lot of work to do tonight, man. Long leg over the hypotenuse. Now, I need a long leg and hypotenuse. What would that be? 15 and z. So 15 and z. Anybody have any doubts about that? So z is equal to 225 divided by what? 13. So z is 225 divided by 13. So y, all right, is going to be 225 over 13 minus what? 13. 13 is 169 13ths. So that would be 56 over 13, obviously, right? If you don't like that, just type it on your calculator. 225 over 13 minus 13. Go. 225 divide. Just listen to me. I hear, trust me, I'm not that old. All right? 225 divided by 13 minus 13. Math, enter, enter. That's the quickest way to do it.
And then it comes out as a fraction?
Yeah, that's been going on now for 2 years.
Oh my god. I didn't know that. What?
That's because you pay attention 50% of the time.
I think you should look like
Yeah.
I still got it. Yeah, what?
Did you get that?
It's 56 over 13.
Man, that was
Might
pretty
have
good.
to work. It's not bad.
Mine got 4.30.
Math, enter.
Math.
225 divided by 13 minus 13.
Minus 13.
Math.
Ah.
Oh,
Y'all very surprised.
wait, square root.
Or you could just
No,
multiply
math and not work is square root.
13 times 13 and then
Okay, so to figure out what x is, again, the last thing we need to do is figure out what x is. So it would be 56 over 13 over x. Short leg to long leg is x over 13. So you end up with x squared equals 56. So x is equal to 2 radical 14. I hope you're listening. Go.
How did you know this?
Short leg, long leg. Short leg, long leg.
So
56 over 13 is short leg to long leg. Is equal to short leg to long leg. I'm trying to figure out what x is.
So y is 56
Times 13. Cross multiplying.
Oh,
Right? And 13 times 1 over 13, those cancel.
yeah, I got it.
So, the answer, okay.
All right, listen, we don't have enough time. All right, so number 12. All right, it's an isosceles. So this becomes a what? 9. Then we do Pythagorean theorem, so we would just say 19 squared is equal to x squared plus 9 squared. Right? 19 squared, I believe, is 381. 61 or 81?
81. One thing or 9 times 9.
It's 361.
361.
Yeah,
Thank you.
361.
Thank you very
Oh, I
much.
thought you said 61 for 9 squared. I didn't
Alright.
say that. I said
19 squared is 361, right? Okay, thank you. Then subtract, so that becomes right.
2 radical 70.
Yeah, I'm agreeing with you. Good job. 2 radical 70. Good. That's how I want it. Girls, listen. You're. Any objections to that? Yeah, it's the same problem. All right, this is a 5. And this is an 11. Same problem. All right, this is 13. Same problem.
So it's 5 on each side.
Okay, now, again, that was just 10 squared plus x squared equals 37 squared. Now, look at 19. All right, for 19. All right. Well, we're doing the triples, right? So this is 2 times 8, and this is, so it's 8, 15, 17. So I really would kind of want you to look at that and say that was 30. You're correct. What?
And what if you were to just do 6 foot square?
Yes, do it the long way.
But that would
Yeah. What? Yeah, the triples that you should know, again, let's take a look at that. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are just good to know. You don't have to. Like we said up here. If you're not looking for them, you have a calculator. It's not a big deal. It just takes time. That's all.
Number
All right, we're getting there.
Oh, good idea.
Yeah, okay, here's where we get into the 45, 45, 90 stuff. All right, so it says the length of the diagonal is 30 radical 2. The length of the diagonal is 30 radical 2. The side would be what?
The side would be
30.
16. Oh, wait, no.
30.
30, right?
Because it's double it.
The side would be 30.
Oh, right, it's just
Divided by 1.
So the perimeter would be,
they give us
120.
like the
guys, hold up just for a second now. Listen, I'm a little nervous about tomorrow. I keep saying this is easy, but you got to know the rules. And some of you guys are, acting like you've never seen it. It's going to be hard. All right, some of you ask me about the perimeter of a square if the diagonal is 30 radical 2, and you don't even know what the side of the square would be. You got to look over all those rules. I'm telling you. Anybody have any questions of why the perimeter is 120? Yes.
Because, so, the diagonal, well, I did this problem, and I got the right answer. So, I used to decide the square as like 15 radical 2, I would take the side, and that's right.
Oh, just watch, please. Make yourself a little square. So there's my square. Here is my diagonal. That is 30 radical 2, which makes a 45, 45, 90 right triangle. So from last Friday, we learned that if the hypotenuse is 30 radical 2, the leg would be what? 30. Right? What?
Oh,
Brilliant. It's a 45, 45, 90 triangle. Because the square is an isosceles triangle. Right when you draw the diagonal. Okay. What?
Oh, sorry, no, I'm sure.
So y is 5.3 radical 2
X is 45.
and x is 45.
It's the same thing.
for the next five.
No, you don't know that, Bruce. It's different numbers.
No, I mean X's. No, how do you response? There's so many different things in the shop.
This one's easier. Because you just add a radical 3y is
30, 60, 90. So it's radical 3. The hypotenuse divided by 2 is the short.
You guys just keep talking. You guys, girls, just go sit outside. Feel free. You have the freedom to go do that. No one cares. Be quiet.
So
X is 15 divided by 2.
Y is 15 over 2 radical 3.
Exactly.
15 radical.
Yes. Either way.
Would you accept 7?
Is it the same? We don't use decimals.
So the short leg
So it's another 30, 60.
the short leg is double the hypotenuse.
Listen to what you just said. The short leg is twice as big as the hypotenuse.
Sorry.
What did you mean to say?
I meant to say the short leg times 2.
Right.
And then the next one is 16 over 2 and 16 radical 3.
Listen to what you just said.
X
is 8,
Oh, 8.
and y
Sorry,
is
I just
8
did the
radical.
same thing.
I looked at that completely wrong. I had 16 over 2, which
I
is
believe
8.
you.
Yeah.
No, you're not.
Right there.
No, you're lying.
I'm not joking.
Go back up. Go back up. 16. Why is it that the one before was 15 and now this one's 8?
What are you talking about?
There's different triangles. One is wait, it's the exact same triangle. It's 8. No, one's 15 and one's 16.
Yeah, but it's just.
Why is one 8 now? And then why was the other one the same number?
What's 16 over 2?
15 over 2 is not that.
8 is half of 16. Oh, that's an actual math problem. Yeah, I got you.
That's why Sam said 7.5 is okay. It's the same.
Yeah.
It's too fast.
Me too.
Time alone you're doing that.
Okay, this is what I needed.
It's just 2,
Guidance.
30, 60, 90 triangles.
So the
What?
hypotenuse. So the x is 17.
I understand.
Everyone
X is
knows
17.
17.
And Y is what?
Y is 17
Radical 3. Because
Wait,
that's
30.
the short
Just
leg.
isosceles.
X is the short
Or
leg.
no, not isosceles. They're
Same triangle.
I don't know this is
That way you listen.
180, 60, 140.
All right, here we go.
use a triple, so it's a 3.5. So it's the other side 200.
No, you're doing the
Oh,
trigonometric
so like
ratio. So
cos
you're doing like
or-
sin.
Yeah, it's 250
Yeah, but you
because
have
it's
to
the
take-
340.
Yeah, no,
the other
So basically what they're asking is this. This right here is the angle. This is the opposite, and this is
Oh,
the
you want like
adjacent. So this would be tangent of theta is equal to 160 over 120, and of course we reduce that, so that would just be tangent theta is equal to 4/3.
It's 0.02.
Nope, you just leave it. They just want the ratio. That's all they want.
And I have a question. What are the, so you can't use a Pythagorean triples for that?
If they were asking what's the hypotenuse, you would use the triple.
Oh, but it's asking.
They're asking for the trig function that's involved. All right, 39. Here we go.
Don't want to.
The angle formed to the ground, to the top of the building. So generally, everything is going to be written as a what? Very good. Right triangle.
Right triangle.
You read my mind, Mr. Stroud.
All right. So when we draw a right triangle, it says the height of the Empire State Building is 1,472 feet. Find the distance from the Empire State Building. All right, so this person is standing at a horizontal ground level with the base of the Empire State Building. All right, the angle formed to the ground and the line segment from its position to the top of the building. So basically, the angle of elevation is what? 48.4, right? Find the distance from the Empire State Building. All right, so they're trying to figure out how far away the person is.
From the base or the top.
So we're looking at this right here. So what are we using on this? Tangent. So you would be saying the tangent of 48.4 is equal to So you should be able to say x is equal to 1472 divided by the tangent of 48.4. And what is that?
1306.
1,306.90.
Same thing.
Whatever. Okay, so let's just do 41 real quick. It says, a space shuttle is 1 kilometer above the sea. All right, so from here to here is, that's the sea, so this would be 1. And then it says the space shuttle begins to climb at a constant angle of 3 degrees for the next 80 ground kilometers. So let's see what that means. So it's climbing at 3 degrees, right? So here's what I'm trying to draw for you. So this right here is a 3-degree angle, right? For the next 80 ground kilometers. Why do they think you used 80 ground? Because they're measuring that, right?
So they're calling
Not
it
the
that.
climb, right? It could have said he was traveling for 80 kilometers. If he's traveling for 80 kilometers, it would be that, all right? But that's not what they're saying. So the question is now, how high off the ground, all right? To figure out how high off the ground, we're going to figure out what this is, and then we're going to add what?
1.
We're going to add 1. All right,
Is there the space shuttle 1
kilometer off the ground.
That makes
Right?
we
So
want-
again, here we say
it's 10.
tangent of 3 is equal to x over 80. So x is equal to 80 tangent 3, which is roughly what?
4.2
4.2 plus
plus 1 is 5.2.
4.2 plus 1 is 5.2 kilometers in the air.
Why is it tangent? Oh, 6 degrees, yeah.
All right, let me see. 44, how do I solve 44? I'm looking at 44 real quick. What do I do for 44?
Don't you do the inverse of sin?
Yeah, inverse sine. So K is equal to the inverse sine of 0.8499.
8.2.
Okay, so please look real quick at 45. Solving the triangle just means find the missing parts. All right, so everybody do me a favor. All right, at 45, you should be able to look at the missing angle and say the missing
22.
angle is 22 degrees. That's not hard. All right, now let's find the hypotenuse. Or we have to use trig to find the hypotenuse. So I'm going to choose the 22 degrees, the 11, and the x. So the 11 compared to the 22 is the what? Adjacent, right, over the hypotenuse. So the adjacent over the hypotenuse is cosine of 22 is equal to 11 over x. So x is equal to 11 divided by the cosine of 22. Everybody with me on that?
11.
11.86.
So this is 11.9, right? Now, to me, honestly, with that number on my calculator, I would just do Pythagorean theorem. So do the number on your calculator, just hit the square button, minus 11 squared equals, and then take the square root of it. And what is that? What is it?
It's like 4.5.
So approximately 4.5. I don't care. It's just a squared plus b squared equals c squared. So the answer that you had in your calculator, squared minus 11 squared equals, then take the square root of that, right? Now, let me just show you something that's kind of important. So I'm going to make this y over here. So I'm trying to show you that it doesn't matter, right? So now I have y, 68, and 11. So in this case, I want to do the tangent of 68 is equal to 11 over y. So y is equal to 11 divided by the tangent of 68. Do that and see what happens. Same answer, right?
Well, similar.
That should be exactly, right? If you use the exact numbers in the calculator, it'll be exactly the same answer. If you round, it's not going. If you round, it's not going to be the same answer, right? So you see the point, right? It doesn't matter how you do it. What?
So, because we were trying to find the side,
Right. You can, and you.
used regular tangent.
Well, no, it's just a matter of this, buddy. It's not about side. It's that I'm missing this side. Why? So I used 68, this, and this.
I just don't understand when you use inverse.
You're using inverse when you're looking for an angle. If the angle is missing, you're using inverse sine, inverse cosine, inverse tangent. In other words, if I gave you this problem right here, and I said this was my triangle, and I said this was 8, and this was 3, what's that angle? You would say the cosine of theta is equal to 3 over 8. So I'm looking for an angle, so I know I'm going to do the inverse cosine. Whenever you're looking for an angle, you can do inverse cosine. And by the way, if you looked up, well, never mind. What?
You do number 57.
Yeah, let's look at 57. Oh, yeah, this is similar. Or you're going to have something like this, so let's see. So, again, basically, you're looking at something like this where you're up in the air, correct? So, a traffic helicopter pilot 60 meters above the ground spots 2 antique cars. The angle depressions are, so, right? So here we go. So we're looking at the first car right here, right? So this right here would be X, like a car. Let's just say car 1 or whatever, right? This is car 1, all right? So that angle of depression, we could just say right here would be 10.2, right? You agree with that? So then this right here would be 10.2. Do you agree with that? Now, the next one I'm going to try to show you right here is car 2. Now, how did I know it was further down the road? The reason why I knew it was further down the road is because it has a smaller angle. Very good. So look right here, please. So this right here, and you can see the logic here in a second. This angle right here is smaller than the other angle. Do you agree with that?
Yeah.
So it has to be farther away. You hear what I'm saying? Trey?
Yes.
Right? So now I am looking for this distance. I'm looking for this distance right here. Do you agree?
Yes.
And that angle right here is 8.7. Do you agree with that? So now I'm going to label this y right here. And again, I'm saying this is a good problem because I know this is on the test. All right, but I think I actually draw the picture for you, so it should be pretty easy. You hear me? So now we have that system of equations, right? So we're going to say, I don't know. Well, anyway, I can figure out what y is rather quickly. Do you agree with that? So it would be, I don't think this one is the system. Tangent of 10.2 is equal to 60 over y, right? So then y is equal to 60 divided by the tangent of 10.2. Do you agree with that? So tell me what that is. Somebody.
333.5.
333.5. Now listen to me just for a second. All right. I need to know this distance now. Do you agree with that?
Yeah.
And then I would just subtract, right? So instead of saying 335 plus x, do you agree it's okay? I think it's easier mathematically if I just call that x. But then in my mind, I have to know that I have to subtract 333.5. Do you understand me? So now we would say tangent of 8.7 is equal to x, or I'm sorry, 60 over x. You with me? So x is equal to 60 divided by 8.7. So tell me what 60 divided, or I'm sorry, tangent of 8.7.
It's 392.1.
Is that right?
Yeah.
And then subtract those two answers.
Okay.
58.6.
Sounds about right. You agree with that?
So that's the total distance.
Yeah, the distance between the two cars. I'm listening.
Okay. The little angle that you made with car 2, like how it's split in between, is the little arrow. Is that the angle of 8.7, or
Yes.
is the almost non-existent?
This is 8.7.
Mr. Stroll actually just told me he was so confident about the test, he says he wants to take it tomorrow.
That's not
It's a good idea.
funny.